Well, in the last class we talked about Java threads, and we have seen that the threads are the different the life cycle of a thread consists of 4 states in general, in which a thread you start, then you make the state can be running by executing its run method. It can be suspended by when it goes to sleep, or a method is executed, or it waits for another message from another thread by notify or notify all. When the running the method run execution is over, it is terminated. Now, as I had mentioned in the last class, the two threads can be threads can be running concurrently. Now, question comes that how do they communicate and how they synchronize. The problem of synchronization is very important. For instance, that suppose this thread, let's take, say there is a value of x. X is, they say, for instance, is the account of a person in a bank, and it is updating this account. Now, if this thread is updating the value of x to, say, x plus 100, say rupees 100 rupees has been deposited, and similarly this thread is also tries to operate on the same account by the taking that x plus x minus 500, so it is withdrawing. Now, unless, and both of them, since they are working concurrently, if they want to access the value of x simultaneously or try to modify it at the same time, the value of x that will be performed will may become inconsistent. And so what is necessary, that you try to control the access to this variable, to this account balance, by one thread at a time. That means when this thread is executing with x, this should not be allowed to modify the value of x again. And otherwise, when this thread is executing, it sees that it has deposited the value of x, 100 rupees, and later on during its execution it tries to say that display x. It will find that say if x was originally 1000 rupees, and in between this one is executed, that instead of seeing that x is equal to 1100 rupees, that's what this thread expected, it will find that it is actually minus 500 to 600, that is x becomes 600 rupees. So in between, if this at this point, when after executing 100 and in between this thread execution is performed, so the same value of x will now be displayed as 1100 minus 500, which will be 600. On the other hand, if this one, while executing x1, and then you have a display here x, and at this instant of time, and say after it has deducted rupees 500, and then in between this is executed, and suppose initially it has seen the value of x was here it saw the value of x equal to 1000, it knew that it has removed 500 rupees. Now at this point, when it displays, it finds that instead of 500 rupees left, it will find 600 rupees left, because in between this one has been executed. So this is what we call the problem of accessing the shared variable or shared area by two concurrently running programs or processes, or in this case threads. This problem of synchronization or access of processes, concurrently running processes, is well known in the while we people studied the process synchronization, and there are several methods available, one of which is the concept of semaphore. Here what we like to do in this type of situation, that this kind of erroneous values which are coming because two processes are executing concurrently on the same data, is that somewhere or other we must allow only one process, or in this case thread, to access the data at a time. That means until this T1 thread is finished with the execution of x, once it has grabbed x, that it will not allow anybody to modify the x or access x and that is why we will need to lock this one, this shared data item. So therefore, when we, as we have mentioned, that the threads are essentially concurrently running program codes, and even if they are executed, they may be executed in the same machine or in multiple different machines. It is necessary that whenever they want to access the same common object, it will be necessary to restrict the access of the object by in a suitable manner, and that is what is meant by the synchronization. This is what is achieved by appropriately synchronizing the threads. So the concept of the threads in communication and synchronization is that whenever two or more threads intend to access a shared resource, in this example the account balance, it is necessary to synchronize the threads so that only one can access the thread shared resource at a time. So, and again, to achieve the synchronization, the shared objects need to be locked. Take the example as just now I mentioned, that how do you first of all proceed in this kind of situation, and here the in Java, in fact, the idea is that we have to somewhere or other support the mechanism of locking the threads, so locking the objects which a thread can access. In the operating systems environment, people use the concepts like semaphore, so that the accesses are mutually exclusive or concurrent processes. In the current environment, in Java what happens, Java uses synchronized keywords to implement such critical access, control the accesses of a shared data item. So what is happening here, the uses the synchronized to implement critical action. Whenever a control enters a synchronized method, say of an object, the thread that called the method A, say like in this example, suppose this thread has called the method update x. This is update x 100, or you can have a method called deposit x 100, and here it is a debit x 100. Now whenever it is calling a method, say deposit x 100, which is, if it is a synchronized method, then the thread that called the method A, so in this example say T1, it will lock the data at object X, and so that no other thread locks the object A, and so whose method has been called, and until this object A, Y is unlocked, no other thread can call the synchronized method. So therefore call another. So therefore if both these methods are synchronized, the deposit and the debit, no other object will be able to call this or use this X, object X. Now this is the basic idea of synchronization, and which is supported in Java. So therefore what happens, that therefore whenever you want to access a particular object by making them mutually exclusive, we can use the construct synchronized method to do that. And in this environment, in this situation, Java will automatically lock that instance, and no other method will be allowed to, no other synchronized method will be allowed to access it. Now again, one more thing, Java locks are per thread. That means if a synchronized method is invoked inside another synchronized method on the same object, it will not be locked. So the locks will be released only when the outermost method returns. So what we are seeing, therefore, that it may so happen that inside this method, this thread T1, you may be allowed to access X using another methods of X, because thread T1 has already locked X. So inside the method update or deposit, whatever you call, we can again call another deposit or any other, say display or any other display X. So inside the code deposit code, I am perfectly allowed to to use another method inside the code for deposit, we can use a call, say, display. Now, even though this is you accessing some shared resource, since the T1 has already acquired lock or has been allowed granted access to this to X object, it can go on utilizing it, and no further, no, there will not be problem. So therefore, Java locks are per thread, means once a thread acquires a lock on a particular object, it can go on using it inside it, inside it until it comes out of the original method which has locked it, original synchronized method which has locked it. However, it will deny another object, another thread T2 to access it. So this is useful, because otherwise we cannot, that is the same thread may require to lock the object X, that is if T wants to display it again, then if it is denied, then T1 also cannot access X, and that will be very inconvenient. And therefore, the Java lock, this is what is meant by Java locks are per thread, and the lock will be released when the outermost method returns. So you can have a method, synchronized method inside, and within it there may be other methods which can go on accessing the same object. A typical way of declaring the syntax or declaring synchronized method will be something like that. Let us say we define a class account, and in which this is the account balance we had been talking about, and suppose there is a method called float read balance, that is display I was mentioning before, so and return this balance. And then public synchronized, here this is the keyword synchronized, is a synchronized method, deposit balance, and so float deposit, and you just increment the value of the amount. So here in this case we have, instead of display, I have used the read, and this is the deposit, the two methods. And the one thing that needs to be observed is that synchronize this keyword, and it means that whenever such a method is executed, it will be it will deny access to any other thread. Whenever such an instance is executed, it will deny any access to any other thread on the account balance. To illustrate this thing further, let us take a typical example, which is a classical problem in operating systems books, what we call the producer consumer problem. So here is happening is that a producer is supposed to, the example is that producer is producing some item, say X or data, and it is producing this, and consumer is supposed to consume it, that means it is taking it. There are several applications in which this producer consumer problem is can be modeled in this framework, that you have a same data item which is being shared, which is the data I called, is being shared by two. In the operating systems case, people explain it with the help of processes. We have producers and consumer, two concurrently learning processes. One trying to modify the value here, writing some value here, another is reading from it. That's sometimes called reader-writer's problem. You can think it of in the classical. Another way is that, for instance, we have say in a stock market environment, say that one is selling stock and another is buying stock. So basically this is also can be modeled in the producer consumer framework, and what we will now see that how this problem, in which we have a producer is a concurrently running process and a consumer is a concurrently running process, and the data is shared among them, how they can be implemented with the help of this problem, with the help of Java threads. To look at this problem, I define two methods, one class called class myThread, which has a private integer data, that is the data which will basically be shared, and I define two methods inside it. The one is the two synchronized method. One is get. Get is that wait for producer to insert a data value. The data value will be inserted by the producer, and it will wait and catch interrupted exception E. This is a class I am defining, and exception has been caught. And then after that, let us look at the concept of the producer. The producer implements the runnable interface, a my thread, and as I mentioned that there are different ways we can implement the producer and the that is the runnable run method. So implements runnable method and producer my thread thr, and this producer, this is the constructor, and this is the producer starts. And what the producer does, the public, that the run method, in this it just puts, it uses a put method in the class my thread, which I will explain a little later, and then increments the value, puts the value here, and that is whatever the j values are, this value will be incremented and run. Similarly, we have the consumer, which will implement, that is the again that is a consumer thread. The consumer implements runnable, and this here, this is a new thread is created, that is two threads I have mentioned that I need to create two threads, producer and the consumer, which are communicating. So this is one thread, this is the producer thread, and this is the consumer thread. Now these two thread instances, as the previous one showed, that the producer thread is created here using the using, and it is run using the run method of this, which if what it tries to do, it is essentially tries to put into the value of data, increments the value of data. And similarly the consumer, which is again another thread, is started and it tries to get the value of data. So now let us come back to the thread my thread class, in which we would like to, what is put method is. In the put method, what we try to do is that we here is the put method. In this put method, if you remember that in the class my thread I had defined that there exists a variable boolean free equal to false, which was initialized to free. If not free, that if false is free, then we are getting, that is to wait for producer to insert a value, data value. That means until something is put, nothing can be get, consumer cannot consume it. And then here, when it is waiting for the consumer to get some value here, and then it catches the and after that, when it acquires the method, that means when it tries to print the value of method when the free is true, then it prints the value of m which is being provided with, and then makes the false to be free, and then notify the producer that data value has been retrieved and return m. And similarly, that is the value which is being read, has been provided with will be returned to the consumer. Similarly, in case of a producer will check that if this is free, that means whether the value, data value is if nobody is accessing it, then that means somebody, if it is free, then somebody wait for consumer to get the data value, that is consumer is trying to get the value of the data, and then it waits. And when the consumer has finished, if you remember the code for the consumer, that once the consumer is finished, it will be then it will raise an exception, and then the exception is caught, and after that it will print the value of the data, which is that this m is dot m is equal to n and free is true. So this, actually this should be equal to n and free equal to true. Here this should be data. So what is the repeat? What is the get is doing? Get is waiting for the producer to insert a data value initially. Whenever the producer has inserted data value, it prints the value of data and makes free false. That means nobody else can access it at the moment. And then notify the producer that the data value has been retrieved. So it has to notify it. So because consumer is waiting for the data and return the value of data. In case of a put, it that is producer is putting some value of n, and so it waits that if at that instant of time, if the consumer is accessing the data, say for instance producer wants to put a value of n equal to say 200, it wants to wait till data value has been consumed, and once it cannot proceed, so it waits, and then once the consumer has finished taking the data value, it will then use this data value, return and push this data value into store it in n, and after that it will proceed. That means n will be put, data will, this 200 will be put here, so you will get 200 here, and then free will be true, and then inserted value is n, and notify the consumer. Note that word notify the consumer that the data value has been set. So this is notify all. So what is happening, therefore you can see that this class thread which is using with the help of synchronized method. So once this synchronized method, these two methods get and put which we have been talking are synchronized methods, and both of these methods are synchronized. So therefore it is not possible, and the data being a private of class of my thread, so in any instance of data can be accessed only through get or put, and once the get is executed, no other thread can access this data value. So therefore what is happening is that when the producer thread is executing, if it gets the value of data, if it executes, the producer executes the put method, then consumer thread will be prohibited from executing it from its get method, and once the producer thread finishes the putting the value of data it wants to, then it will inform the consumer that I have put the data value and you are free to access it, and at that time the consumer can access the data value using the get method and show the result. So therefore what is happening, that even though these two can run concurrently, what is happening, using the keyword synchronized, we are effectively blocking the access of the shared data here one at a time, and this is how a typical synchronization or the producer consumer problem can be resolved, in which producer can go on producing as many data items as it likes, the consumer can go on consuming it at any in a different rates, and so this is a very simple example. We can see that in this case, if we allow a data to be stored into a buffer, so that means large amount of in this case we have only allowed data to be one element. So if say for instance first of all there is no consumer program is running, say first instance producer produces, say this is the producer, it say executes put 200, consumer has not done anything yet, so the value of data will be 200, the old value will be lost. Then again if producer again performs put, because no consumer may be there, so it may be say 500, data value will be 500, but this value has not been consumed by consumer because it was running if you have started it late. But if consumer has started somewhere here, then consumer can do one thing, it can access this data value here at this instant of time. But again, after that, if no producer runs, then the consumer will again get the same value. What we have not done in this simple example is that, or rather we can modify the simple example as to create a buffer sort of, in which producer can go on pushing the values into the buffer, and the consumer can say, for instance, this is the producer first puts as a value of 200 and then 500, then this is the producer is doing it, P produce the port 700, and from the consumer can go on, this is the producer is going on reading it, and this is the consumer is going on reading it, and from a data buffer. But however, in that case, it will be necessary to slightly modify the program so that situations do not happen in which buffer becomes empty and yet consumer wants to read it something from the buffer, or producer goes on producing something here, and the consumer, instead of reading and that is producer is producing at a slower rate as compared to the consumer, or the consumer is reading at a slower rate, and that is a buffer overflow because the producer is producing at a faster rate. Now those modifications can be easily incorporated in the basic simple program. However, the basic idea should be clear that the usage of the keywords for the get and the put has forced the access of the producer, that is this thread and this thread, to be mutually exclusive on the data value that we have, which is a shared data item. Now also you should note that in a synchronized method, the locks will not be released till here the producer executes the notify method. So therefore producer should have a call here, notify all, like the consumer has done. So therefore we can until this statement is executed by the producer, no other consumer can access it, and after that or when the producer finishes execution, then consumer can access it. So therefore this is one way of enforcing the this is the way we can enforce the synchronization with the help of the synchronized methods. And here we have used the keywords or rather the concept of runnable interface, implement the method runnable. We have consumer class is implementing the runnable interface for my thread class, and that we had already seen, because the basic thread class, the method that is being it does not really support the run method in any practical run methods, and the next another way of doing the synchronization in this example, what was there is that we have written our own synchronized get code. But suppose that we need to have code, we use codes which are written by other people, and we want to yet synchronize the objects. This can be done by a very simple mechanism which Java supports, that in this case, to synchronize objects having no synchronized method, just use this keyword synchronized, the synchronized expression statements to be synchronized. For example, we can have a public static method A float data, and then we can say the synchronized data. So therefore, whenever the synchronized block, any block of code in Java can be synchronized using the word keyword. So whenever you are accessing this board of the code, then only one thread will be allowed to access it, the other threads will be locked out. Another way is that create an extended class. Say for instance you have defined a class in which no method is synchronized. All you can do, other approach would be that create a subclass of it which extends the methods using the keyword synchronized, and then use the children class, the child class, for implementing the synchronization among the threads. So besides the concept of synchronization, so therefore, or rather the synchronization, the inter-thread communication in fact is Java, as we have seen in example. The methods supported are wait, that tells the calling thread to go to sleep until another thread enters the object, and calls notify. For example, if you look at this code here, it waits whenever you are executing the this thread has was a thread consumer, say let's say the consumer thread has entered this code, is executing the get method. It will wait till when? It will wait till another thread enters the same object, and that means it enters, that is the producer thread, which can access it, uses enters the calls notify. So therefore, once the producer wait for producer to enter a data value, and then it will it can wait and start consuming the values of whatever written. Similarly, the notify wakes up the first thread. There are two more concepts of notify. One is notify all, and another is notify. It wakes the, in case of a notify, wakes the first thread that called the wait on the same object. Notify all will wake up all the threads which are waiting for that object. And these methods must be called inside a synchronized method. That means this is a keyword. So wait can be used inside get wait, call can be used inside a synchronized method. So also the notify all or notify. So like we had done notify all inside get, similarly we have done notify all inside put. So these are the ways the Java supports inter-thread communication. And lastly, one more thing, that we have seen that the Java, in Java, whenever a process is ready, it can go on executing, and there are different states in the Java class, and one of which is that it is whenever you are creating a Java object, you are then it is in a run state. It executes the run. However, while for scheduling the Java objects, what we often do is that in this case, whenever the new Java objects are started and it's running, now normally the schedule, that means there may be several threads which wants to run, and out of them normally the Java will be selecting them based on their priorities. And so therefore, if you can define the priority of a thread, that means you can assign it a higher priority, will be given will be given more preference in running as compared to the other threads which are also in a runnable state. So this is the thread scheduler uses thread priorities to decide which thread can run, and this can be changed with the help of the concept changes priority between minimum and maximum. A typical thread is that when you create the thread, my threads, a test thread, with the thread priority is +2. Say whatever the normal priority is a standard priority, and on more than that, that is, if the other jobs are of normal priority, then this test thread will have the higher priority and will be given preference while scheduling or execution whenever a new as compared to the other threads which are waiting for execution. So what we have seen in these two lectures is that what is a thread, how do the threads can communicate with each other, that is what are the inter-thread communication, how do you synchronize it, which is very important, as we have seen, particularly when we are looking at the concurrent access to a particular way with the same object, and it is necessary to synchronize them, and the Java supports the two approaches, one using the synchronized methods or using a synchronized expressions, and that is how we can create a critical, we can ensure that data values which are that is the access are never, that is the shared data value is never read or written by by two different threads in a manner such that there will be error in execution. And we have also seen that how to start a thread, how to create a thread, how to suspend a thread, and how when the thread terminates its execution. And so therefore we are now we should be able to use the threads and create a client server environment communication, and in which we will see that in the next class that server will listen to the sockets and will try to initiate a communicate will be and will fork or will rather create a thread to serve the requests of the of the of the client, and yet goes on listening to the socket for other clients to communicate.